Right now, we're going to wrap up oxidation and reduction with one addition to this. At the moment now, I hope you can see all that. You have a copy of it. Number 7 is laboratory test for oxidizing agents and reducing agents. I have in my hand the mandatory list of experiments. You all have a copy of that which you got in class from me. So you have that, and I'm on page 3 of your notes as well, so that you'll know exactly where you are. In the mandatory list of experiments, there's an experiment there, number 9, that's neglected by many candidates. Don't become one of them, will you please? Number 9, I'm reading it to you now. It says, redox reactions of group 7 elements. That would be group 17 in the periodic table. It would be the halogens. Okay, so that's what we're talking about. Halogens, it says, as oxidizing agents, and they specify the exact reactions they want you to carry out. Okay, now they are as follows. It says reactions with bromides, iodides, iron 2+, and sulfites. They named these 4 reagents, and they've asked you to show that halogens are oxidizing agents. So I'm going to do something on the board for you. This would need to go into a practical notebook as well in due course, but you need to add number 8 onto the bottom of this list. Just put in number 8 as mandatory experiment number 9. Okay, it's number 9 on this list from the State Exams Commission, so you need to make sure you have that. And you can put a title on it, halogens as oxidizing agents. Okay, now I'm briefly going to talk to you about that because we need to go a little bit further with it in due course, but I need to talk to you a little bit about what's going on there then with that, okay? Now, bear with me a sec. You all know halogens are on the right-hand side of the table. They are group 7. And if I took any one of them, like chlorine, we'll say, chlorine, I'm looking up it's number 17. You'd look that up too. There's 2 in the first shell, there's 8 in the next shell, and there's 7 in the last shell. Now, what you need to realize, of course, is that chlorine, all atoms want a full outer shell. It's called the octet rule. They'll do anything to get 8 on the outside. So that particular atom would love to gain electrons. Okay, very important. Let me take another element here for a moment. Let me take sodium, a metal on the other side of the table. Sodium is number 11. And if I wrote the electron arrangement for number 11, there'd be 2 in the first shell, there'd be 8 in the next shell, and there'd be 1 in the outer shell. Now, can you see the stark difference in the 2 of these? This is a gainer of electrons because it loves to become a full shell of 8. And this is a loser because it would like to become a full shell of 8. Okay, this is a choice of gaining 1 or losing 7. So obviously gaining 1 is much easier. This is a choice of losing 1 or gaining 7, so it loses 1. So I think you've heard me say this before. All metals are losers. That's very important here now with oxidation and reduction. All the metals are losers, okay? They all tend to lose electrons, okay? What does that mean? Oxidation is the loss of electrons. They're easily oxidized. Okay, and what about the non-metals like chlorine? Well, they tend to gain electrons, okay? That's reduction. They're easily reduced, okay? They're excellent oxidizing agents. If they're easily reduced, they're excellent oxidizing agents. And I'm staying with that for the moment now because that's the thrust of this particular piece, okay? Now, I'm putting this up here on the screen just to let you see the arrangement. Please understand that this is a mandatory experiment and you probably need a bit more help with it than I have here. But don't worry about that. I will in due course refer to it again. I just want you to see what you're dealing with for the moment. I'm checking all the time that you have some view of that you can see what's happening. I give you several versions of this now. You do not need to take that down. You do not need to take it down, but there are 4 of them there, and I have to be careful that you have all 4, okay? Just going to move that a little bit for you. Make sure that you have that, okay? That looks okay now. I want to make sure you're reading it correctly. An experiment to show halogens as oxidizing agents. Now, please don't take that down. You'll be totally confused. I'm going to do something much easier with you now in due course, but I'm going to describe the experiment first for you, okay? I'm going to describe it firstly, so bear with me. I refer to this particular experiment as the 4 test tubes and the 2 beakers. Now, I know you're worried about me now, but will you take it, please? It's just a way of, it's only a colloquialism for what we're doing. You'll be 4 test tubes, put 4 reagents into them, and see how a halogen would affect each of them. That's basically it. And we have to do 2 beakers then with 2 metals, and I'm going to deal with that. Remember now, it's an experiment on oxidation and reduction. An experiment to show halogens as oxidizing agents. Halogens love to gain electrons. That means they're easily reduced, so they're excellent oxidizing agents. Now, please, you need to think that through. That's very important that you're working on that. So I'm talking about, you know, the 4 test tubes for a start. Let me do them. You put 4 test tubes on a test tube rack, and you put the nominated solutions from the list I've just read from you into these, okay? You put the nominated solutions into them, okay? Same amount of solution into each. They're all more or less colourless. They're close enough, okay? The order doesn't matter. Now I'm going to tell you what they are. This is potassium iodide. They say on that mandatory list an iodide, any iodide. So that's potassium iodide, okay? The next one there is a bromide. I'm going to use sodium bromide. NaBr, sodium bromide, okay? Now I'd love to demonstrate all these, but it will take forever, and frankly I can't justify this in the medium we're working in at the moment, okay? The third one is a sulfite. Okay, so any sulfite will do. SO3 is a sulfite. I'm putting sodium in front of it again to keep life simple. If you want a potassium sulfite or you want a potassium bromide, that'll be fine. Whatever is available, but it must be an iodide, a bromide, a sulfite, and the last one there, will you be careful, is iron 2. Okay, they write it as Fe2+. I'm going to write it as FeSO4, so, iron 2 sulfate. Okay, and they're the 4 reagents. That one has a pale, very pale green colour to it, almost colourless. I'm happy to tell you they're all colourless. There might be a bit of an exaggeration. I'd like to see you doing them because you'd at least investigate that a bit better. Now, what we're going to do is we're going to pour a halogen into each of them. Cl2 solution is what I'm going to say there. And you get a colour change for each of them, or you get a change that you can verify. And that's very important. Now, I'm stressing again to you, this is a mandatory experiment. I read the context of it for you, and I'll be repeating it shortly again for you, okay? They say the effect of a halogen on an iodide, a bromide, a sulfite, and an iron 2. Now, you make up these aqueous solutions, and you'll pour chlorine solution into it. Where would you get chlorine solution? Not chlorine gas now, okay? Chlorine solution. Bleach would be lovely. You could pour some bleach into it. I did that one for you just a moment ago, just to illustrate that. I'm not going to do them all now because it will take too much time, and we need to make sure we have our material covered, okay? But will you take it, please? That's what you do. You set up your 4 test tubes, put your 4 solutions into them, and you add, and you observe what will happen. And what will happen in each case, there'll be something observed. This iodide will go to iodine, and it will go brown, okay? It will go from colourless to brown. Okay, it'll go from colourless to brown, right? And that would show that you have, I'll talk to you again, that you have oxidized the iodide to iodine, okay? Iodide to iodine. I'm going to give you a little template for this in a moment. I prefer now, other than the diagram maybe, that you'll be taking nothing else down. Okay, just the diagram. Okay, that goes colours to brown. This is bromine, right? This is bromide. And when you pour it in here, it'll go from colourless, I'm going to say to yellow. Now, when you do some organic chemistry, you'll find that bromine, the bromide goes to bromine. You'll find that the bromine is a yellow colour, and it disappears in the presence of any unsaturated hydrocarbon. I'll be doing that in the next video, by the way. It will come up and we'll deal with it there. But it basically changes colour because the bromide becomes bromine. In other words, it has been oxidized. That has been oxidized by this particular thing. Okay, so remember now, that's going into each of them. That solution is going into each test tube. Now, in this case, what happens? It goes from colourless to colourless. That's great, isn't it? In other words, there'll be no change in colour. When you add the oxidizing agent in there, it will oxidize this, but what will happen? It'll go from sulfite to sulfate. It will become Na2SO4. Now, folks, this is an eye test. You have added an oxygen, and adding oxygen is oxidation. That's an oxidizing agent. It oxidized that from sulfite to sulfate. I'll write it down here, SULFATE, sulfite to sulfate. Okay, now basically you have mandatory test on your course. I haven't done with you now, but you have a mandatory test on your course. I listed them a while ago to test for a sulfate and a sulfite. So you would test some of this before you started, and then you'd add that in, you test it again, and you'd find you had a sulfite before you started, and you'd a sulfate when you're finished. So the test for sulfate would have to be done there. Now that's in another part. I've told you already now, don't get too frustrated with that now. It literally means you have to learn the recipes. 5 tests. I've listed them at the beginning of the last video now. Chlorides, carbonates, hydrogen carbonates, nitrates, sulfates and sulfites, and phosphates. They're the 5 tests you have to do, so be careful please. That's sulfate. And the last one here is iron 2, and what will happen of course is it will go to iron 3. It won't change very much at all, okay? It will go colourless to, I'm going to say colourless again, okay? That's not quite true, there'll be a slight green tint in it, but basically it goes to iron 3, Fe3 plus. 3 plus, from iron 2 to iron 3. Oxidation number +2 to +3, it's been oxidized by the oxidizing agent. There's a test you have to do for iron 3. You add sodium hydroxide, and you're going to get a precipitate which looks like Connemara marble. There'll be a yellow fleck through it, a bit of brown in it, okay? But it'll basically be a precipitate. Are you okay with the idea of a precipitate? It means that the clear solution goes cloudy, okay? And that stuff is insoluble when you add that, okay? Now I'm just saying to you that is the test trick. Now I need to help you with that. Now, so what do you need to record now? You have nothing in your notes on this. I'm referring to these as the 4 test tubes. You must be able to tell me what's in each of the test tubes. And you must be able to tell me what you would see when you'd add the oxidizing agent. We're trying to show that halogens like chlorine are excellent oxidizing agents. And that's correct. So chlorine is put in there, some bleach put into each of them. That goes from colourless to brown, that goes from colourless to yellow, that goes from colourless to colourless, but you can prove you've got a sulfate. You have a test on your course for that. This goes from colourless to colourless again, but you can prove it's iron 3 by adding some sodium hydroxide. Now I understand you might be taking a lot in there at once, but I would need you to take that down. So you'd be pausing your video and taking that down, okay, to get a sense of where you are. I'm referring to them as the 4 test tubes, and I'm going to give you a template now shortly to explain that. Is that okay? And that's what we're about to do now. Now let me just look at what's on the screen for a minute, even though I don't think that's that helpful. I don't want you taking this down. I'll ask you to take the next piece down. When you add chlorine solution to potassium iodide, you get iodine, which is the brown colour. When you add chlorine to sodium bromide, you get bromine, which is the brown or the yellow colour. Brown is a deep yellow, okay? Yellow just to distinguish there, that's okay. When you add chlorine to sulfite, you get sulfate. Would you be asked to write that equation? No, I'll give you an easier one in a moment. Look, it goes from sulfite, which you can test for, to sulfate, which you can test for. You can prove that the sulfite turned into sulfate by doing that test. Now, if you haven't done yet, just put an asterisk on it. It'll be done later. Don't worry about it, it's fine. And lastly, iron 2. There's iron 2 there in the iron sulfate, and it goes to iron 3 sulfate. And you have a test for iron 3 sulfate, which is what you want. Now, I have a much easier version of that for you than that, and I want to use it now for you. I'm just showing you various versions of this, so you'll get used to all this. It could get very confusing if I didn't kind of show you a variety of things on it, and I'm doing that right now. Now, please, again, do not take this down. This is too untidy altogether. I'm going to give you a much easier version of this, okay? Bromine for a start, okay? There's the bromide, and the chlorine reduces it to bromine. You get the yellow colour. There's the iodide, and it goes to iodine, which is the first test tube there. There is the iron 2, and it goes to iron 3, and there's the sulfite, and it goes to sulfate. Now, I couldn't possibly expect you to know all that. Okay, we need an easier version than that. So what I'm going to do is I'm going to give you a template. And this is the bit I want you to record. It's very easy. Now, this is a little gimmick I'm going to engage with now for a moment. Okay, basically you have 4 test tubes. Now, focus on this now, please. I want to see that everything is okay there with that, and that you can follow that up. Sorry, I'm just checking my camera to see that that'll be legible enough for you as well. That's okay. I just need to see you're okay for the moment. Now, hold back a moment. You can pause your video. Remember to take this down. Now, please, the 2 previous ones, don't even think about taking them down. This is the one you'll be recording. This is my template now to make life easy for you. I don't believe in rote learning, by the way. Okay, so just accept that you have to have some logical trend of thought when you're actually trying to reproduce a material, okay? We're going to put chlorine into a solution. It's going to change to something else, and it's going to, obviously, the chlorine is going to be affected as well by that. You need to know. So that could be this stuff, or it could be this stuff, or it could be this stuff, or it could be this going into that box. So you remember the template, and the rest of the equation will remain the same all the time. Okay, if you put chlorine into potassium iodide, you get iodine. If you put chlorine into sodium bromide, you get bromine. If you put chlorine into a sulfite, you get a sulfate. And if you put chlorine into iron 2, you get iron 3. And I have them here for you then, and that's exactly what you do. But the template is the most important thing, that you have this structure every time. If this comes up in the exam now, that's what you write down in your exam. and fill in the 2 boxes. And you'll be finished. That's exactly it. Now there's 4 of them there, and because they're mandatory, they consider them quite important. So I would want you to be recording each of these in turn. Okay, now it would be nice if you took a separate page in your own time. Now remember, this is easy as you're listening to me now. You can pause the video later, go back and construct this, a single A4 page, right? And you'll go through this exactly like that. Now this is for preparing you for the exam. As regards your mandatory practical notebook, you'd be writing this into the notebook and you'd be saying clearly what you did. I set up 4 test tubes and I put these reagents into the test tubes. You'd be saying that. Okay, very important. And then you'd be saying along the way, you know, when I added that, this went from colourless to brown. Okay, that means iodine has been produced, chlorine is therefore an oxidizing agent. Okay, then you added in here, it went from colourless to yellow, therefore the bromide has been oxidized. Okay, has been oxidized, that's been oxidized, that's been oxidized, the oxidizing agent is working. The sulfite becomes sulfate, but there's no colour change here, you tell them that, it stays the same. I take some of the content of this test tube and do a test for sulfate, and it's positive. So the sulfite has become sulfate, so that's an oxidizing agent. And lastly, some iron 2 solution, you basically pour the oxidizing agent into it and it remains colourless, but when you test the resulting solution with sodium hydroxide, you get a precipitate which proves it's iron 3. Now, there's only 4 there and they can't ask you anything else. They can only ask you an iodide, a bromide, a sulfite, and iron 2. They won't pluck anything out of the air and say, what would happen here? Just be aware of that now. And the problem, unfortunately, in Leaving Cert is any one of them could turn up in front of you. What would you see happening if we added chlorine solution too? You see, and it would be one of these. It might have nothing to do with the practice at that stage. It could be anywhere in the paper. Because it's mandatory, there's an expectation you have it done. So that's what would go into your practical notebook with a clear account of the fact that you've got this to act as an oxidizing agent and oxidize each of the 4 of these. But as regards reproducing the equations, here's a neat way of doing it, and I'm going to ask you now to be aware of that. I've left all the padding out now, just the bare minimum here. When you react this with potassium iodide, I've only written the iodide ion. You get iodine, that's colourless, that's brown. Okay, and you always get that. Look from your template, you're copying it, right? Next, when you add chlorine solution to sodium bromide, you get a colourless solution starting off and it turns yellow. It turns brown if it's very concentrated. Okay, but yellow to just distinguish, right? And consequently the same again. Okay, that's the oxidizing agent, so it is reduced. That's the oxidizing agent, so it's reduced, right? 0, oxidation number, -1. 0 to -1 is reduction, very good. The oxidizing agent is reduced. -1 to 0, that's oxidation, that has been oxidized. Now please, I'm copying the template and that's what I want you to do. That's the second test tube. The third test tube, sodium sulfite. Sodium sulfite. Sulfite is SO3, sulfate is SO4. Be careful, please, okay? And therefore, that oxidizes that to that. Even as an eye test, oxygen is added to that to get that. Oxygen is added to get that. Okay, and there you are again. This is reduced, of course, the oxidizing agent is reduced. Same template, very easy. Now, because they're both colorless, you have to do a test for a sulfate. Now, put an asterisk on that if you haven't it done already. I don't think we have that done, and I don't know whether you did it with Sarah or not. But if you haven't it done, just make a note of it. There is a test on your course. It's part of the mandatory list for testing for a sulfate. Okay, no problem with that now. I just don't want to go there at the moment. It's very simple. Okay, you add 2 reagents, you add barium chloride, you get a precipitate, and one dissolves and one doesn't. But don't worry about it. There's a test there for it. You can deal with it in your own time. And lastly, there is the iron one then. The iron 2 goes to iron 3. That's +2 to +3, and consequently, you have a full test there for that. Now, that's very important that you'd be aware of that and that you'd have a sense of what you're doing there. Now, that's as simple as I can make it for you, and that's the page I'd want you to transpose into your notes. That you take an A4 page, that's the template on top, and you have just 4 possible reagents. You're showing that halogens act as oxidizing agents, okay? Very important, okay? An experiment to show that halogens act as oxidizing agents. And we've taken chlorine. Now, please, I'm reminding you, when I write chlorine like that, you may be thinking it's chlorine gas, which is very dangerous. It's a chlorine solution. You can put solution in there if you want. But you see the template, that's the important thing for you. Anybody ask you any of these, write down the template and fill in the 2 boxes. They may only ask you one of them, but you'll find it very easy to do that then in that case, and that's what I'd ask you to do. I wouldn't worry about balancing the equations. I wouldn't worry too much about it. There are spectator ions often missing, right? You could have a 2 in front of that to make that up, but don't worry about that. That's a minor detail. It's really about taking the rote learning out of this and making something logical of it, and I hope that's okay with you, is it? So that's the halogens done. Now, there's one last piece to this mandatory experiment, which I must deal with now. The 4 test tubes I've dealt with, I'm going to get rid of them, okay? That will be for a practical notebook. That is for your regular notes. That's for your regular notes, okay? But that will go to practical, and you tell me exactly what you added and what you saw happening. Okay, what you saw happening, that will be very, very important. Good. Now, we have to do a little bit on metals. I mentioned, remember the halogens are non-metals. And so the halogens are excellent oxidizing agents. They're easily reduced. Metals are losers. Okay, they're easily oxidized. So in fact, we have to show redox with them. Okay, and that's what I'm about to do next with you. Now I'm reading from your mandatory list of experiments again. At the very end of 9, it says displacement reactions of metals. And it only mentions 2, and they're the only 2 they can ask you. Zinc in copper ions, which means copper solution, and magnesium in copper ions. And that's effectively what they want, nothing more, nothing less than that. So let me put that up there for you, that you'll have some sense of what you're doing with that. Displacement reactions, there they are at the bottom of the screen now. Okay, there's only 2 of them there. If you were to take a solution of copper sulfate, which is blue in color, okay, and you put a zinc rod into it, that's zinc, and this is copper sulfate, CuSO4. Do you all know that copper sulfate is blue in color? Do you all know that it's blue in color? Okay, and that's it there. Okay, blue in color. Basically, what will happen in this particular instance, you get a reaction taking place. There's the zinc, there's the copper sulfate, and it will go to zinc sulfate plus copper. Now be careful how you're reading that you're reading it correctly. Can you see on the screen that I have the ionic form of it as well? When you write a copper ion like that, you mean it's part of a bigger molecule, it's part of a compound. Okay? And likewise there, it's part of a compound. So what has actually happened is the zinc displaces the copper out of the copper sulfate. It goes in instead of it and releases copper. And they would ask you, you would be asked, what would you observe when zinc is placed in copper sulfate? It wouldn't have to be a rod now, that's just for convenience. It could be granules of zinc in there. What would you observe when that would happen? And the answer is very simple, really. Look, that's a blue color. And as time goes on, you have less and less of that. So the blue is going to fade away. The blue color of this, don't say disappear now, you're suggesting it would react completely, and it doesn't. It will take years to go colorless. But will fade. The blue color will fade, and you'll find specks of copper metal. There, look, you're actually producing copper. Specks of copper will be found inside the tube. Okay, very important. Now, why am I doing this then? Now, I'm probably giving you the impression that if you put a zinc rod into copper sulfate, that would start going pale before your eyes, and that the copper will be seen inside there. No, I'm talking, leave it there for an hour or 2. And you'll see things happening. If you left it overnight, left it for the weekend, you'd find there'd be a significant change when you come back to it. And that's effectively what you need to realize here. If you do that, it'll be fine. I'm going to put oxidation numbers on it to show you what's happening. Okay, that's 0, free element. Okay, that's oxygen -2 4 times. Copper is +2, and therefore that's going to be there. That's going to be +6. This is -2 4 times. Zinc is +2. And therefore that must be +6, and that's 0, free element. So look what's happened. The zinc has gone from 0 to +2. That's an increase, that's oxidation, that's a loss of 2 electrons. Life would have been much easier if you used the ionic form of it, wouldn't it? Look, that would go from 0 to +2, and that would go from +2 to 0. That's okay, I'm only doing this for practice, okay, that you have a sense of that. So this has been oxidized. And look at the other side, the copper goes from +2 to 0. +2 to 0 is a decrease, that's reduction. Reduction is a gain, it's a gain of 2 electrons. So this has been reduced. What's been reduced? That's been reduced. Now be careful you don't say the copper has been reduced. There is no copper there. That's copper sulfate, that's a solution. That is not copper, that's a copper ion, and that happens to be blue. You all know the colour of copper, don't you? A copper pipe is a kind of a golden yellow colour, yeah? That you'd know that, and that's metallic copper, okay? So it's the copper sulfate that has been reduced. So that's a redox reaction. Metals are always undergoing redox reactions because all metals are losers. All metals are losers. And it's the same then with the other one. It's the same with the other one. I'm just going to do that for you, just to do the second one to make sure everything is okay. The magnesium is placed inside the copper sulfate solution again. Magnesium often comes in ribbon form. Ribbon form, there's your beaker of copper sulfate, and it's a bit of ribbon, okay, it's on a roll. You can get granules of it too. The granules will be just chucked into it and left standing for a period of time, okay? And what you'll find, as in the last time, you'll get magnesium sulfate, and you will get, of course, you'll get a copper as well, okay? And remember, that's blue. We've told you already that's blue. That's blue in colour, and you know that the specks of that will be there. And as before, that went from 0 to +2, and that goes from +2, the copper goes, let me put it in there, +2 to 0. So 0 to +2 is an increase, that's oxidation, okay, and that goes from there to there, +2 to 0 is reduction, very good, so that's a redox reaction. So the metal has been oxidized and the copper sulfate has been reduced, or the copper ions have been reduced. And that's very important. In any reaction involving a metal, where the metal is on the left-hand side, the metal is always the loser. It is always oxidized. Now, I keep asking chemistry students to latch on to that word always. It's a great ground rule and leveler for you in exams, because when the examiner gets smart with you and changes the example, you're going to say, but sure, that's another metal. And if it's another metal, it's going to be, of course, oxidized. Okay? That's always oxidized. Never anything else. And that's very important for you, that you go about it like that. If you do, you'll have no issue at all. Now, that completes all the oxidation and reduction completely. And I am saying this to you now, it's so important with every section you study in chemistry, that you complete it. It's so important that you complete it, that you get to the stage where the entire category is covered. Have you all written in, now I'm asking you before I finish, have you all written in number 8 here? Number 8 is the mandatory experiment, halogens as oxidizing agents and displacement of metals. Displacement of metals. Now, that's the entire section. Now, please, if you're having trouble with anything here, you need to go back up to here and get this right first. That's very important. Now, you have a very good standard there now. If you'll follow that through, you'll be well capable of any question you'll be asked on it. All right? Good.